This is Alkenes and welcome to this video, and we are going to talk about chemistry, and specifically we'll be looking at the isomers that we looked at. Now in this video specifically, I want to share with you how you can be able to name isomers in the type of hydrocarbons which you are calling the alkenes. Now if you are one of those who have followed my videos on YouTube channel, please I want to help you understand that we'll be dealing with the alkenes. Now, just to give you a summary about what alkenes are, okay? So alkenes are also compounds that we are calling hydrocarbon compounds, and they have, between the carbon to carbon, they contain a double bond, okay? At least one of the bonding between the carbon to carbon should be a double bond. Now, the difference between the alkenes and the alkanes is that the alkenes are also called unsaturated hydrocarbon, while the alkanes are called the saturated hydrocarbon. Now, specifically in this video, what I just want to show you is how you can also understand isomerism and what are some of the procedures when it comes to nomenclature, okay? How you can name an isomer that have got a nature of an alkene, or that have got a double bond in it, okay? So if you're new to this channel, please don't forget to subscribe, like, and also share this video. The more you do that, you guys, we are so much very delighted, because when you subscribe, we are also trying to reach a wider audience, okay? So if you have not subscribed to my channel, please, I want you to encourage to say, please do subscribe, because once you subscribe to the channel, once you do subscribe, then you'll be able to know when Alkenes, as YouTube channel, we have posted a new video, so that you'll be the first person to actually know that there is a new video that has been uploaded. So now, without much further ado, we are going to let's now jump into the isomerism, okay? So if you do understand what I said in the last video, to say isomerism, these are compound, okay, or isomers, these are compound that have the same molecular formula but different structural formula. So we are going to see in the alkenes, okay, we are going to see in the alkenes that how can we come up with a different kind of a structural formula, but while we stick to the same molecular formula of a particular actual class member of the hydrocarbon of the alkenes. Okay, so now here's a simple example. We have this one. Okay, so now what you can see on the board is actually a compound, okay, a structure of an hydrocarbon. Now you can see that the double bond is normally what tells us what kind of an hydrocarbon are we dealing with. Okay, so we are dealing with an hydrocarbon compound who is carbon to carbon, is a double bond. Okay, now this tells you to say we are dealing with the alkenes. Okay, we are dealing with the alkenes. Okay, so please don't forget that the alkenes, at least one of the carbon to carbon is a double bond. Okay, so you can see that the structure seems to be very complex somehow. For some of you have never actually understood what organic chemistry is all about. But I want you to understand that in as much as the structure can be so complex or seeming so surprising that maybe you cannot even name provide the actual name of this. So that now brings us to what we call nomenclature of isomers. Okay, how you can go about naming the isomers. Okay, so it is the same procedure that we use in the single carbon to carbon bond, which is the alkenes. Now in the alkenes, the only different way or in the procedure in which we actually come up with the names of the isomer, specifically in the alkenes hydrocarbons, is that we actually identify where, at what position within the carbon, okay, is a double bond occurring, okay, at what position of the carbon is a double bond occurring, okay, and then the whole idea about counting, the whole idea about counting so that we can arrive at that double bond so quick, as opposed we can delay to arrive at that hydrocarbon, at that double bond position. So remember that you always need to understand that the numbering is always very important, okay? So now in this case, if I'm going to start to number from the right going to the left, then I'm going to see at what position of the carbon is the double bond occurring. So is that position where the double bond occurring, is it the shortest distance possible I can ever actually use to track where the double bond is occurring? Or is it the longest distance possible that you can delay in order to arrive at that double bond is occurring? So you ask those two questions. Then what will also help us to solve the question of whether we arrive so fast at the double bond or we delay arriving at the double bond. So it's a carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6. Okay, so when you look at the numbering, right, I start from the right going to the left. What this means is that I just want to track at what position of the carbon is the double bond occurring. Okay, so don't just end there. You do the opposite, okay? So I started from right going to the left. Then I will say I do the opposite numbering. So to see which numbering gives me the correct number. Okay, so this is 1, 2, 3, 4, 5, 6. Okay, so you can see that my aim is to find the position of the double bond, at what position in terms of the carbon is the double bond occurring. So this now tells you to say, if I start from left going to the right, start from right going to the left, okay, then the double bond is occurring on the carbon number 2. So when I'm going this side, because this one is this one, okay. But when I start from left going to the right, meaning that the double bond is occurring at carbon number 4, because I'm moving in this direction. So after this carbon, there's a double bond, okay. So it's a carbon number 4 at which the double bond is occurring. When I start from right going to the left, okay, when I start from right going to the left, okay, so the double bond is occurring at carbon number 2 because I'm moving in this direction, so I have to follow this carbon, this bond is for this carbon number 2. So now this tells me to say the shortest possible, okay, number at which the kind of numbering, okay, I'm going to use, so the top numbering gives me the correct numbering in order to reach at the double bond, position of the double bond, while the bottom numbering system gives me the incorrect numbering, okay. So now, remember, we have also this part, okay. We have this part, okay. So we have this part. Remember what I said, that a carbon that is attached to 3 hydrogen is just the derivative of a methane. Okay, are you getting that? A methane. So this is just a functional group which we are calling the methyl. Okay, just called the methyl group. Okay, that is the methyl group. So after you have done that, you also have to indicate at what position of carbon from this normal chain, the unbranched chain, at what position of the carbon is the methyl group is branching off. Okay, so when I'm going this direction, okay, so the methyl group is branching off at carbon number 4. So now this gives you the correct way or the procedure to follow so that the nomenclature, okay, nomenclature becomes the correct one in terms of what kind of the name is this isomer that I'm dealing with, okay. So this one will be okay. So you say what you're going to do is it is 2, okay. You write 2, meaning the 2 is the position of the carbon at which the double bond is occurring. And then the dash. Now you ask yourself, what is the root name of this structure or hydrocarbon which has got how many carbon? 1, 2, 3, 4, 5, 6. Okay, so an hydrocarbon with 6 carbon is called an hexene. Okay, an hexene. Okay, it is called an hexene. So that now gives you the first part of the nomenclature. Okay, now the second part of the nomenclature is going to be the naming of the methyl group, which has actually branched off from the 4th carbon, which is this one. So this is going to be 4 dash methyl dash. Okay, so that now gives you the name of this structural isomer. Okay, so if you're having challenges, please, I encourage you first of all to sit down, understand some of the procedures that you need to follow when you're coming up with this kind of the name, okay, that you can use. So our name is actually now called 4-methyl. So 4-methyl 2-hexene. Okay, so that now tells you to say the name of this isomer, the structural isomer that we have drawn on the board is called 4-methyl 2-hexene. So the hexene part is actually the root name, the parent name, which is normally the Greek name. Okay, so hexene is just an hydrocarbon, okay, which is unsaturated hydrocarbon with 6 carbon in it, okay, and that is called hexene. Okay, so if you want to actually be receiving most of my videos, all the content that I do post on this channel, please, I will encourage you that you click on the subscription button just down below this video. You click subscribe, and then you see the option that pops up, and then you click all. Now, once you click all, that means you'll be able to receive all my videos from this channel, Radical Academy. So help us subscribe now so that you don't miss any video content. And once you subscribe and click all option, then that simply means that whatever kind of a video that we do post, you'll be the very first person to be notified, so that you don't miss any single video, because you want to pass your exam. And before you know it, Radical Academy is the best YouTube channel for education content. We provide all the examiner questions and key concepts. So help us by subscribing to our channel so that you can also help you too. So let's look at the last example on how you can also, just to try to dig more and actually understand how you can name another isomer. And then, what is up, guys? So welcome to this second example about isomers in alkenes. So remember, by the way, alkenes are the double bond, okay, kind of hydrocarbon. So they are also referred to as unsaturated hydrocarbon. So by the way, if you're new to this channel, please don't forget to subscribe, like, and share this video so that the more we actually post a kind of new content such as this one, you'll be the very first person to get notified. So make sure that you click on the subscription button just on this channel so that whenever we upload any kind of a video, okay, you'll be the very first person to be notified. Okay, so now let us solve this example and see how we can name, or what kind of a name we get from this kind of a structure. So I want you to understand that when you're talking about organic chemistry and specifically the alkenes, okay, kind of hydrocarbons, what comes into our mind is that these are hydrocarbons, okay, that have in them the double bond, okay. So at least between the carbon to carbon, you can put the double bond, okay. You can also put whatever you want, the double bond, at least, okay, one of the carbon to carbon is a double bond. What that means is that that is the way we can identify that we are dealing with the hydrocarbons that are, of course, called the alkenes. So now, how do we go about providing the exact name about this hydrocarbon, okay, which is an alkene? So we don't know yet what this is all about, okay? So all we know that we have to provide a name. So the thing that you're supposed to understand, of course, is the numbering. So I talked about you have to ensure that you number, you identify where the double bond is located. Once you identify where the double bond is located, actually, and then you should also identify if there is any substituent group, okay, like the ethyl group, like the methyl group, propyl group, like also the butyl group, and also the pentyl group, just like that, okay. So now, the key thing in coming up with the name of an isomer is to understand, more especially under the alkenes, make sure we understand where is the double bond occurring. So at what position of the carbon is the double bond occurring? Once we identify the double bond, position of the double bond where it is occurring, now we can also be able to identify, okay, if there is any other kind of, kind of the thing that can help us to come up with the, the correct name, the actual name, by following what we now call the nomenclature, okay. And by the way, when you look at this part down here, so this is a part that is now branching off from the main, this parent kind of a normal chain and branched off chain, okay. This part is branching off. Now when you look at what is branching off, you identify, or you discover that there are two carbons within this group that has branched off. Now, when you go back, you discover that an hydrocarbon compound which has got two carbon in itself is normally called an ethene, or if you want, an ethane. Okay, so eth means two carbon. Okay, be it in alkenes, the double bond hydrocarbons, or ethane in alkanes as a single bond hydrocarbons. So what this entails you to say, you have these two carbon. So it tells you to say it is coming from the actual name hydrocarbon called an ethene or ethane. Okay? But the fact that it doesn't have complete number of hydrogen as in the normal ethene, then this simply means that it becomes a group called an ethyl group. Now, when you go back on top, this is the normal chain and branch chain, okay? And you can see there's a double bond there because that is very cardinal. I'll show you in a minute why. Now we count the counting procedure is a two-way counting, okay? So if I start from right going to left, then I would number it as 1, 2, 3, 4. Okay? Now, once you number like that, from moving from right going to left, you should also do the same, moving from left going to right. So this is going to be 1, 2, 3, 4. Okay. So now you compare which of those numbering, the top numbering and then also the down numbering. So the one which gives you the shortest number, okay, the shortest number of the carbon position at which the double bond is occurring, that is the correct numbering because that is what we want. So when I count from the top numbering 1, 2, 3, so the double bond is occurring at carbon number 3 or position number 3. What about the other way around? Okay, so 1, okay, 1. So at this carbon going from left to right, 1, okay, we have the double bond. So the numbering on top is actually incorrect, okay, it's actually incorrect, while the numbering at the bottom is correct. So we are going to follow the bottom numbering so that you can also identify this ethyl group. At what position of the carbon is it branching off from the normal hydrocarbon? So if I follow this one, so 1, 2, 3. So at carbon number 3, this is where the branching off is taking place. So the name is going to be, you start with this this one, the ethyl group. So you say carbon number 3. So the 3 means that this ethyl group is taking place or is branching off from the normal hydrocarbon at carbon number 3. So 3 ethyl dash. Okay. 3 ethyl dash. And then you come to this part where the double bond is occurring. So at carbon number 1 dash. And then you count now the number of carbon in the unbranched off carbon, unbranched off hydrocarbon. So 1, 2, 3, 4. So the hydrocarbon with 4 carbon is called butane. Okay. Okay. And now that gives us the question, or that gives us the name of this structural isomer in alkenes. So, ladies and gentlemen, if you have more challenge, please, you can also drop your comment. You can also, comment. You ask question in the comment section so that we can also follow up and just try to help you so that you really understand what is that we are trying to teach you. And once again, please don't forget to help us, support us by subscribing to this channel, by clicking on the subscription button, and then you also select the option called All. And then you click on that option All, then you are home and dry. So every video, every kind of a topic, regardless of the subject, you'll be notified that Radical Academy has posted a video. It's bye-bye. Thanks so much for watching.